Slightly bigger picture. Do you remember that we had three ways to find the power series for a function? One of them was the 1 over 1 minus u identity. What were the other two? 1 plus u to the r, the binomial series expansion. And the third one? Yeah, to use a Taylor or Maclaurin series. And this one, I can look at an x squared times 1 over 1 plus x. So what I'm going to do is I'm going to start with 1 minus u. I'm going to plug in u equals negative x. Then I'm going to multiply by x squared. Get x squared times 1 over plus x. Now let's do this one in sigma form. Make sure you're comfortable with both. So in sigma form, it's 1 over 1 minus mu looks like that. And we make the substitution u equals negative x. We like our power series to look like the x by itself. And then if I multiply this by x squared, so there's my f(x). The nice thing about interval of convergence for these problems is we already know the interval of convergence for this. This is a geometric series. It converges as long as the u is between negative 1 and 1. So I did the substitution u equals negative x. The interval of convergence for this is negative 1 to 1. Then I think I'm having you go into f prime and the antiderivative. It's just asked for the radius of convergence. Let's go to interval. So for f prime, it's going to be a sigma negative 1 to the n and plus 2 x to the n minus 1. Did n equals 0 correspond to a constant or to a term with x in it? So I'm plugging n equals 0 in, there's still an x. So that's derivative is not going to disappear. So there's still an n equals 0 for the sigma. And notice what I did is to do the derivative, I just pulled the exponent in front, like regular derivatives. And the new exponent is the old exponent minus 1. So for interval of convergence, it's still negative 1 to 1. Converges here, diverges out on the end. And that derivative is just going to make it bigger. We know that it already diverged at the endpoints for the original. So if we made the endpoints bigger, it would still diverge. So the interval of convergence for f prime is 0. I'm sorry, it is the same as it was before. The radius is 1. The center is 0. this way. So remember the sigma form was we had this. So I'm just going to write it this way. First of all, you see this is a geometric series. 1 plus 2. In particular, what's the A? The R? Here's, what do we want? Go with that? So remember, the sum of the geometric series is A over 1 minus R. Well, actually, in this case, it's 1 over 1 minus U. So that's where, well, for this part, we're turning around. We start with the 1 over 1 minus U, turn it into that. And then for a geometric series, what do you know about the R value to get convergence? So not every geometric series converges. Like if I have 1 plus 4/3 plus 16/9 plus 64/27. What's the R here? 4/3. So getting from one term to the next, by multiplying by 4/3. Does this geometric series converge to diverge? It diverges. So R has to be in a certain range in order to get convergence. So that's the idea. We're just kind of going backwards from our geometric series. Antiderivative of the f function is the sum from 0 to infinity. Constants just come along for the ride. Add 1 to the exponent and multiply by the reciprocal of the exponent. So just basic integration. It's x to a power. The antiderivative is x to a power that's 1 bigger, and we divide by that. Center is x equals 0. The radius r is 1. Okay, now we made each term smaller. So the original terms just had the x's. Now we've divided them by n plus 3. So it's possible that the endpoints end up converging. So we're going to have to plug in. Negative 1 to the n, x to the n plus 3. Plug in x equals 1. Negative 1 to the n, 1 to the n plus 3 over n plus 3. No matter how many times I multiply 1 by itself, it stays 1. So this is negative 1 to the n times 1 over n plus 3. Converge or diverge? Converge. It's an alternating series. Same expression. X equals negative 1 in there. idea is I want to split negative 1 to the n plus 3 into negative 1 to the n times negative 1 cubed. Clean up. Look at that. What's negative 1 to the n times negative 1 to the n? It's just 1 to the n, which is 1. And what's negative 1 cubed? Negative 1. So the series ends up looking like negative 1 over n plus 3. Converge or diverge? Diverges. I want to make one mistake, by the way. That was an indefinite integral, so there should be a plus c somewhere. I should get that in your notes. So the interval of convergence for this